Right.
All right. So hello, everybody. Today we are going to talk about the book Thinking in Systems, Not Code. And we are here today with the author, Ankit Naik.
Hello, Sergio.
Mhm.
Yes.
And I'm just software engineer, and we're going to talk a little bit about the book in question.
Yes. And for
Mhm.
people who don't know me, I'm an applications engineer working in the Wolfram Math Core group. And Wolfram Math Core is a group who maintains or who is creator of Wolfram System Modeler. Yeah.
All right. So I guess the very first question is, what motivated you to write this book?
Yes. So the thing was, I've been working with clients from academia and from
Mhm.
industry for the past 8 years, and I've been working on modeling systems. And when I was doing my bachelor's and master's, I was taught, like we were taught to think in steps. So, for example, I was taught like how to get the efficiency of a heat pump given some input temperatures and output temperatures
Uh-huh.
and things like that. And I was taught how to solve such systems or such exercises. But when I joined, and I'm in the past 8 years, when I uh, work with uh, companies and researchers, what I found was the real world is not that trivial, right?
As usual.
And it's not exercises. You have problems like the cooling of this building is not sufficient.
Mhm.
How do you improve it? Uh, or things which are more on the problem side, and you have no particular definition of the problem.
Mhm.
And how do you go about in solving those real world problems? And past 8 years, I have been using systems to model and understand and trying to troubleshoot problems. So, through this book, I wanted to share my learnings and the big change which I found
Mhm.
in my schooling or in my bachelor's and master's compared to what I saw when I worked. So that the message of why one should think in systems is what I wanted to present in this book. And what I mean by system is basically three things. A
Mhm.
system is basically has different components in it. So when you
Okay.
have when you say talk about a system, it's basically you have different components, and
Mhm.
those components are interacting with each other.
Uh-huh.
And the objective of the system is to solve a purpose. So those three things is what define a system, and that's what I mean.
Mhm.
And this book is primarily sharing my experience over the past 8 years uh, of what I've learned.
Right. So you saw this gap between what you learned in academia and what you did professionally, and now you're trying to bridge that gap.
Yes, at least
Mhm.
this is my first try.
Nice. Yeah.
Yes.
So you talk a lot about Modelica in the book, and I wanted you to say something about.
Yes.
Uh-huh.
So this
Mhm.
approach of thinking in systems has been facilitated by this language called Modelica language.
Mhm.
So Modelica language is a modeling language
Uh-huh.
that is used to model systems.
Mhm.
And by systems, it could be like engineering systems, like a model, heating of a house, or you can have systems like in organizations, like people move, like a sales funnel in a company, like you have customers moving through different stages of a
Mhm.
sale process. Uh, so uh, the Modelica is a language which gives this features through which you can represent the different components, their interactions with using specialized connectors, as well as uh, you can define those components using equations. I think I would, if I don't want to go into a lot of details into the
Sure.
modeling language,
Mhm.
but
Mhm.
three things I think I would like to highlight that with Modelica first, it is equation-based language.
Okay.
So that what that enables you is that when you create a component, you describe uh, the working of that component using first principles.
Mhm.
So if it's an engineering component, you use your physics equations to define the component. Like for example, if you're modeling a resistor, you just define V equal to IR, the Ohm's law. You don't have to define sequentially, like current is
Mhm.
the input, and from the current, how do you define the voltage? You don't define like that. You just give the equation,
Right.
and the system identifies by itself how it should be solved, in which order, and things like that.
Uh-huh.
That brings me to the second feature that I
Uh-huh.
wanted to highlight is Modelica is a causal language.
Okay.
And by a causal language, I mean uh, it's like how real systems work. You don't define the input and output.
Uh-huh.
For example, you have a water pipe. You don't define which end is the input, which end is the output.
Mm-hmm.
Both ends can act as an input and output depending on the resultant configuration or resultant or boundary conditions.
Uh-huh.
And through Modelica, you don't have to define input and output. Those are automatically identified based on the usage of the system. So first is it is equation based, second acausal, and third thing that I think is important is it's a hybrid. It helps you in hybrid modeling, and by hybrid modeling, I mean like you can integrate continuous systems with events.
Mm-hmm.
So in hydraulic circuit, let's say you want to, so things are moving in a continuous manner, but at a certain point you want to close off a valve,
Right.
right? So that's the event that you want to trigger. And then what would happen? And that is the most common thing that happens in real world.
Right.
It's not just continuous thing, but there are some um, events that happen. And Modelica allows you to model those kind of hybrid models with continuous systems and events. So those three things, and there are a
Mm-hmm.
lot of other features, but I don't want to highlight that.
Uh-huh.
But for people who are new to Modelica language, it's a modeling language that allows you to create systems and gives you a way to define the interconnections between systems.
All right. So something that I noticed in the book is that you cover a wide spectrum of fields and in your examples. So I was wondering, like, how is that connected to the topic of the book? Uh-huh.
Yeah. So I have
Mm-hmm.
like included um, 7 different use cases, and the idea was not to show that you can use thinking systems thinking in it was not to just show that different types of domains you can use to model, but the idea was to show that the way of systems thinking, like thinking in components, interaction between components, is reusable across different domains.
Okay.
So, for example, in a grid, you have energy flow across components, right? So you have some, you can think of it as some stocks, and then there is flows across different stocks, or you can think of a tank and flow across different tank. And in grid, it's a flow of energy. And if you think about in a sales funnel, like
Mm-hmm.
a customer journey,
Mm-hmm.
so it's basically you have unaware customers, they see some ad and become aware. So there's a transition of states. So there also you can think of uh, um, different hydraulic tanks representing
Sure.
different stages
Mm-hmm.
in the sales process. So through those 7 different examples, uh, which are very different from each other, I wanted to show that this thinking in in terms of components is reusable
Mm-hmm.
across different domains, and it's not a domain specific thing, but it's just a way of approaching problems.
I see. So this zooming out kind of works in all of these fields.
Yes,
Uh-huh.
that has been my idea, and through also these examples I wanted to highlight some key aspects or things that you might miss. For example, um, initially I show like how you scale up uh, your system to create to represent something complex. Like in a use case on thermal management of batteries,
Mm-hmm.
what I show is how you start with a simple loop. Then what are the restrictions or what are the limitations of that simple loop, and what you and how you scale to the next step.
Uh-huh.
So how you find out how you start with a simple system, see its limitation, and how you scale up. So you don't recreate a model from scratch, but you are just adding a new component and upgrading it sequentially. And that
Mhm.
way, that was one use case where I wanted to show how things are scaled. Similarly, in there is another example on economics. So it was a Nobel Prize in economics that was given out in 2025. It
Mhm.
was on how knowledge, how we have how we have made so much progress during the industrial revolution. Like, what was the thing that actually led to this rapid increase in knowledge?
Mhm.
And there, I introduced this reinforcement loops.
I see.
So, uh, and then, uh, so the idea behind that was, before industrial revolution, there was not much research. It was a lot of experimentation, and you got an output. And it was, so the learning was very linear. But during the industrial revolution, what happened was, you have a scientific way of thinking. So you did experiments. You
Mhm.
learned from the experiments, applied it back,
Mhm.
and then you created this box of knowledge.
All right.
And then you had this reinforcement loop, which helped you to make rapid progress.
Oh,
And that you see in finance as compounding effect,
I see.
right? So
Uh-huh.
so that loop, that loops you kind of miss if
Mhm.
you are trying to solve things sequentially, because there is feedback
Mhm.
in systems, and things like that. So through all these examples, I've tried to show how the same systems thinking can be approached,
Uh-huh.
or can be used across different domains, and
Mhm.
how things can be scaled, reused, and reapplied across different domains.
I see. So in these times of artificial intelligence and large language models, so there's always the question of how is this related? So how is thinking about systems connected somehow to the artificial intelligence time?
Yeah,
Mhm. Mhm.
yes, I think
Mhm.
uh, with LLMs becoming so good
Mhm.
at writing code, I think what what is more important for us that LLMs fail is, we can define the problem better.
Mhm.
And then we can use LLMs to complement our modeling process. Like, we can use it to understand what are the different components. Some of the components you might not think of,
Mhm.
but you might miss. And then we can use LLMs in identifying the components and how those components are related to each other, and things like that. And once we define the top level structure,
Mhm.
then we can take use of LLMs of writing code for individual components.
I see.
um, so I think as we progress further, and LLMs are getting much better at writing the code,
Mhm.
I think what we should focus on is to be a system architects, and trying to figure out, okay, given this problem statement, how are the different links for this component? What is the relationship between these different links?
Mhm.
And what are the different boundary conditions? And once we have the top level figured out,
Right.
then we can use LLMs to write the codes for individual components,
Mhm.
and then probably accelerate um, the modeling process.
I
Uh,
see. Okay. Uh, well, not quite finally, but also, would you like to leave a message for your future readers about this book in particular?
uh, the thing is, if there is one takeaway from the book, is that one should start thinking about problems as system problems,
Mhm.
trying to identify the different components that affect the system, and what are the relations, like what is the connection between the two, between the different components. So trying to uh, uh, break down a problem into a system,
Mhm.
its constituent components, define boundary conditions, and then try to solve it. So that way is what I would recommend to people who are reading this book. Um,
Yeah.
yes, there is
Mhm.
also there's in the book, one thing I also wanted to mention, that
Mhm.
apart from the use cases, in the last two chapters, I also go into deep dive into how the solvers
Mhm.
actually work.
Uh-huh.
It's not very detailed, but what I also wanted, um through the book is that um, I wanted the audience to understand how tools like System Modeler, like System Modeler is basically a graphical environment through which you can drag and drop
Right.
and create models. And under the hood, the models are written using the Modelica language. So in the last two chapters, I just wanted to to take away the magic, right? So when I talk about, oh, we have components, connections, uh, and you don't need to define the input and output. It might sound magic to a lot of people, but how does the magic actually happen? That has been, I think, 3 decades of work around the compiler or the backend side of things. And through the last two chapters, trying to what I've tried to do is to give an overview of how once you start a model, how things are flattened, how the equations and variables are mapped, and then how the compiler figures out what should be the logical order of solving the different equations, and then how can one select the right states to to break the big system. And I think for people who have used Modelica a bit, or who just want to understand how Modelica works under the hood, the last two chapters are really interesting.
Okay.
It took me 8 years
Fair
to
enough.
to
Yeah.
to understand the different bits and pieces. But I think those two add a lot of value. Like as soon as you start creating models, you get into algebraic loops, or you get into initialization issues, and you need some kind of understanding of how things work. It's basically, if you're driving a car, you kind of need to know how the engine works, just so that you know if something is wrong, which direction you should start to troubleshoot. So I would highly recommend those two chapters. Those are really uh, very interesting. I find them very interesting. Also, there might be some confusion. Like some of our viewers might not uh, know, or might have some confusion of what is system modeler and what is Modelica.
Yeah.
And that's also one of the questions that I frequently get, and I wanted to address it. So as I said, Modelica is a modeling language. So it's an open standard language, and there are many tools implementing the Modelica language. And System Modeler is one such tool. So System Modeler provides this graphical interface where you can drag and drop and create components. But the language used to define these components underneath is the Modelica language.
Right.
So System Modeler is a tool, and Modelica language is a language that System Modeler
Yeah.
is
That
based
enables
on.
that modeling. Okay.
Yes.
All right.
So that is one thing.
Okay.
Um,
Let me just check quickly if there are any uh, questions here that we should look into. Do you want to say something else about like the tools that you used in the book or
Yeah, so
Mhm,
all the models
mhm,
that you can see in the book
mhm,
are done with Wolfram System Modeler.
mhm.
Uh, but along with the models,
Right.
after creating a model, um, there are some analysis that I have done.
Mhm,
Like for example, I remember in the solar rooftop model,
mhm,
I tried to show the, the heating distribution, or the distribution of energy consumption across the 12 different months, and I have different plots for it. And then I have used 3 different locations and compared 3 different locations.
uh-huh,
And for those post-processing analysis, I have used Wolfram language, because once you create a model, you want to test the model with different boundary conditions. You want to do parametric sweeps
mhm,
to understand the sensitivities and things like that. And for that, I have used Wolfram language to for the analysis part, as well as to create those
mhm.
images.
Uh-huh.
Is what Yeah, that's what I've used.
All right. Well,
Yes.
I guess That's
Yes.
probably about what we wanted to cover today.
Yeah, yeah, yes. And this book is
Mhm.
available. Okay, one other thing
Yep.
is I have knowingly kept the book
Mhm.
uh, at a size that I can read.
Sure. Fair enough.
I'm not a fan of thick books.
Yeah.
So, so,
Mhm.
uh, so, uh, so that's why I think I've tried to be concise
Mhm.
in what I'm trying to with my ideas, so people can read through it in 1 or 2 days,
All right. Mhm.
and get the gist out of it. I knowingly didn't go into the syntax of Modelica or into the internal details, because through this book, I wanted to motivate systems thinking.
Mhm.
And once people are motivated enough that it adds value and they understand it enough, then I think there are a lot of other good Modelica books that one can follow to understand the language semantics,
Uh-huh.
and things like that. Um, right. I think we have one question from Greg.
Oh,
Yeah.
let me see. So it says, yeah, so what would you say are the strengths of the Wolfram language in regards to the book or the work that you do in the book? Yeah.
Yes.
Mhm.
I think right. By the way, people who don't know,
Mhm.
Sergio here is the master, or he's the developer behind the integration of Wolfram language and system modeler.
Mhm.
So all the new functions, or the functions, the integration functions, are developed in one way or the other by Sergio. So he knows much more than me. But okay, let's get
Uh-huh.
back
Mhm.
to the question. As I said, like I used system modeler to model a system, but once you have but modeling a system is just one part in the puzzle, right?
Mhm.
Once you have a system, what do you do next?
Right.
So, for example, you have a house heating model. Uh, you have a house heating model and you want to compare it across 100 different locations,
Mhm.
right? So, how do you programmatically get the weather data for a given location, feed it to the model, get the outputs, and compile the results at the end?
Mhm.
So once I had the model to compare the model for 5 or 6 different boundary conditions, I used Wolfram language. And then I plugged in the boundary condition to my model, and I tested different scenarios. Similarly, in the thermal management use case, I show in a hydraulic circuit, you have two different valves,
Mhm.
right? And you have a desired goal. For example, you want to heat something as fast as you want, and you want to see how the openings of the two valve affect that desired goal, right?
Okay.
So then you want to do a lot of parametric sweeps,
Uh-huh.
like the valve opening goes from 0 to 1 and the other 0 to 1, and then you want to see how you want to see the design profile or the compiled result.
Mhm.
And that is one interesting chart where you can see if you're opening one valve, maybe you are going away from the target, and you see if you are changing the other valve, you are coming near to the target.
Uh-huh.
So those kind of analysis where you try to understand how a combination of parameters is affecting your desired goals,
Mhm.
that needs hundreds or sometimes thousands of experiments.
Right.
And that and the integration of Wolfram language allows me to do that quickly.
Mhm. Mhm.
uh, I can go on for half an hour
Fair enough.
on how I use from language, but
Right.
I think I just want to be short.
Mhm.
So that's how I use it.
Right. Okay, we have another question. So there's a question about did anything surprise you from during the writing process? Do you have any advice for aspiring art authors? Mhm.
Right. Yes. So this process of writing started a year ago.
Mhm.
So last year, I wanted to share a lot of my learnings with people out there.
Yep.
Like, I just wanted to share how, um, um, like how things have shaped my thinking, and I
Yep.
wanted to people to just like understand like how what I'm doing. And in the past year, I started writing a lot.
Mm-hmm.
And I wrote 8, 10, 12 different big LinkedIn posts. And I thought it would be a very easy task for me to write a book once I had the post. So I thought, okay,
Uh-huh.
writing a book, I have 8 or 9 different individual posts. Let me just compile it and I will have a book.
Mm-hmm.
But it was very difficult to get a good book because you want to have a underlying theme,
Right.
and that theme should connect all the different stories.
Mm-hmm.
So one should complement that bigger theme. And once I started compiling all my articles, it was very difficult. So I had to remove some articles, rewrite a lot of stuff,
Mm-hmm.
and things like that. So there are two approaches. One approach that I used was like write a lot of small articles and then compile it. It was
Mm-hmm.
very tough because then I did not have a thread to
Right.
connect all the different stories. But now, when I changed my thinking towards thinking in systems
Mm-hmm.
and trying to talk about components, the relationships, and things like that, then I could retweak my learnings or my models
Mm-hmm.
to to supplement that bigger thought or that central theme. So I think if someone is wants to write a book, start with a central theme of what
Uh-huh.
you want, and and what are the different blocks that supplement that central theme.
Uh-huh.
Try to identify it early, and then start writing or creating models or things like that.
Mm-hmm.
So start with the central theme first. Basically,
Mm-hmm.
start with the bigger system, right?
Sure.
What is the purpose of the bigger system? Figure out the different components in that bigger system and how those different
Yeah.
components link to each other, right?
Right. Writing a book is a system, is what you're saying.
Writing a book is a system
I
in
see.
itself,
I see.
right?
That's a good
Uh,
point.
yes.
Okay, we have,
Do you have any plans for future books?
yes. Uh-huh.
One thing
Mm-hmm.
I am dying to write
Mm-hmm.
is book on modeling fluid systems.
Okay.
I found it very difficult to understand the media library, the fluid library that comes with Modelica, like personally, and I spent a lot of time understanding the different details.
Mm-hmm.
I had to create a lot of small libraries to understand the need for a lot of intricacies involved in those libraries.
Mm-hmm.
And I think I've learned so much that I would like to share how those fluid models are built, and maybe start from a simple fluid model and then try to go step by step how I build that fluid library.
Mm-hmm.
That is, I'm dying to write. I'm not sure whether I will have the time or energy, but that is something I want to write.
Right. So this will be very field specific of the
It
knowledge
will
that we
be
have.
on
Yeah.
thermofluid
Yeah.
systems and
Mm-hmm.
starting from like step by step, like how do you define the connectors?
Mm-hmm.
How do you ensure that you have a stable initialization,
Mm-hmm.
robust initialization? How does stream come into the picture?
Right.
What is the need of media and things like that? Like there are so many things I've learned, and I just want to share those with people.
Right.
Like I just don't want to have it inside me.
Okay.
I feel that I need to give it back, but let's see.
Yeah, this is very valuable experience. Like this is not
Yeah,
yeah,
yeah, yeah.
that you have acquired like during your journey.
Lot of failures.
Yeah.
So lot of failures, lot of learnings,
Mm-hmm.
lot of time spent. And I think, and then writing a book is a way through which I compile my failures, compile my learnings. So it helps me uh, to rebase myself.
Yep.
So a lot of learnings, but when I write it, I think that okay, now I have rebased my learning, and I am in a different stage now.
Right.
Now I can move ahead. But with all those random thoughts, if I don't compile it,
Mm-hmm.
then it feels like a mess in my head,
Right.
and it doesn't feel clean.
For sure.
Yeah.
Um, I guess we also have a question. What is your favorite Wolfram function? Um, and how would you encourage users to try system modeler? Mm-hmm.
Right.
Mm-hmm.
My favorite Wolfram function,
Mm-hmm.
uh, uh, and I think this is in context of system modeler and Wolfram language integration.
Mm-hmm.
I think is system model simulate.
All right.
Is the simplest function
Mhm.
that is there. And for me, it is the most powerful function.
Okay.
Because if you do system model simulate, give your model name and give like a range of parameters, like thousand different values of a given parameter,
Mhm.
then it automatically launches, like uses all the cores available in your computer and parallelizes all those simulations,
Mhm.
right? And that is just amazing. I think it's the base for future or different other high level functions.
Mhm.
But I think just if I have mastered system model simulate
Right.
and I have mastered how to get the final results, how to compile the final results,
Mhm.
I think I have done 50% of the post processing work.
Right.
So if there's one function that one should master is system model simulate with
Uh-huh.
all the amazing initial value tweaks, parameter value tweaks,
Mhm.
different inputs changes. That function will take you very far, very far.
Right.
And how would you encourage
Mhm.
others to try out system modeler with Wolfram? Okay, so
Mhm.
the question is, how would you encourage others to try out system modeler with Wolfram? Um, um, I think the first thing would be try to try to find a problem uh, from your domain. For
Mhm.
example, let's say you are in electric circuit course, or and you want to, let's say you are creating a RC circuit, right? So first, like just to start with the simplest of example from your domain, because it has to be in your domain so that you can relate and
Right.
feel the pain, right?
Yeah.
Electric circuit doesn't work for everyone. For me, it was fluid circuits.
Right.
For you, it
Mhm.
might be something else. So start with the simplest of system model.
Mhm.
And then once you have that model, the next thing is use Wolfram language to simulate it for different scenarios,
Mhm.
like for different resistors, different capacitors, and then plot uh, how things change versus, like for different resistance, different capacitors, as I said, have resistance in the x-axis, have capacitance in the y-axis, and just see how the behavior changes. I think that simple exercise like will take you very far.
Right.
Take the simplest of example and use system model simulate to do 100 different runs,
Mhm.
and then just plot two different variables and see how those are interlinked.
Right.
I think that will make your day.
For sure.
Yeah, that will make your day. Uh,
Um, right. We also have a question. What has been one of your favorite projects?
One of my favorite projects.
Mhm.
Um, I think this is available. This was one of a consulting project I did.
Mhm.
It's available online as well, and we have the rights to talk about it, so I can talk about it.
Mhm.
It was this amazing project of having a drone with 76 different rotors.
Okay.
So initially, like I just modeled a drone, and then I was asked, okay, Ankit, can you model this drone with 76 different rotors placed in four different, like spread across four different circular wings.
Mhm.
And then, like, can you just model it? And I said, oh my God, okay, this has so many internal things in it. Like, how
Complex.
do you place different things? Things scale up? But that was really amazing.
Right.
Like, that project I really liked because the the use case was how can you use readily available components to lift a heavy payload,
Mhm.
not making custom complicated heavy duty material, but how can you
Mhm.
use readily available, like that you can get from the market right away. And that was very interesting in the sense you could see that if one thing fails,
Mhm.
is the system able to sustain the flight?
Right.
And there I used a lot of Wolfram language functions to place
Uh-huh.
the rotors at the right positions, because
Right.
in a rotary wing, placing the rotors at the right position
Mhm.
using multi-body components and fixed translations, things like that, is not trivial,
Right.
right? It needs a lot of calculation, and then I had to automate a lot of stuff.
Mhm. Mhm.
And there, for placing different rotors, for parameterizing different
Configuration.
components configuration at the same time,
Yeah.
76 rotor, 70, I don't know, like there is it just explodes. So, and that was very interesting, and
Mhm.
at the end, when I saw the animation, I was really very happy.
Nice. Nice.
Yep.
Yeah, yeah, yeah. I remember that one. Um, right. Here we say, so everyone works with systems, but non-STEM professionals may think that Modelica is just for physical systems. What is your view about
I
this?
completely agree. Like
Mhm.
when I started with Modelica or System Modeler, when I was talking to, when I was going to Modelica conferences, and when I was talking to customers, primarily everyone was talking about STEM related applications.
Mhm. Mhm.
But 3 years back, like uh, we have a business simulation library, freely available business simulation library, based on the concept of system dynamics.
Mhm.
It was introduced to me by Guido Wolf-Rashid,
Uh-huh.
who is the developer and the owner of that library, and I was really amazed.
Mhm.
Right. So, for example, once he introduced me to the concept of system dynamics,
Mhm.
which was pioneered by uh, Professor Jay Forrester from MIT. Uh, there, one thinks about systems as stocks
Mhm.
and flows.
Okay.
And that way of thinking of stocks and flows, like, was so interesting for me that it increased my thinking.
Mhm.
Like like, for example, I started modeling infectious, like spread of an infectious disease like COVID-19,
Right.
where you have people transitioning from susceptible population to infected population to
Mhm.
recovered population,
Mhm.
right? So I'm only considering three. There could be many different stages as well.
Right.
And that one, then I started modeling using system modeler.
Uh-huh.
So, and that was very interesting, where I was seeing how population transitions across the different stages, how the reproduction number, like how many people one person is affecting, like one person can affect 3 people or 4 people.
Mhm.
That is a reproduction number, and how that affects the rate at which things spread, and then we were able to uh, get the curve that,
Right.
yeah, we have seen, all have seen the peak, and
Mhm.
we have been discussing the peak, and that it was very easy to model with system model, and that was really amazing.
Mhm.
And that was the first non-STEM uh, model that I did,
Mhm.
and I was really hooked by it.
Right.
And I was so hooked that we did a study group together. I think you were also part of it.
Right.
We did a study group which was spread across 2 days on guiding principles for modeling and simulation,
Mhm.
where on 3 or 4 different days we only used non-STEM examples.
Right.
We model how CO2 balance affects climate, the global climate rise in temperature and things like that.
Mhm.
We were modeling, um, if I remember correctly,
Mhm.
it was how delays in the vote counting in the US. We were trying to model the delay, and
Uh-huh.
how it can lead to confusions and things like that.
Uh-huh.
And in the book, I have 2 different examples which are non-STEM
Yeah.
related.
Uh-huh.
One is the sales funnel.
Yes.
Like if you are a software as a service company,
Mhm.
what is the journey a customer undergoes?
Mhm.
So, and that is called sales funnel. And there you have unaware customers, aware customers, trial users, occasional users, and then repeat customers.
Mhm.
So there are different stages a customer goes through.
Mhm.
And then there are different things that affect the transition rate across these different stages.
Mhm.
And this is for an organization, and this is completely non-STEM.
Uh-huh.
And that helps you to model something that is really very difficult to model, very difficult to quantify.
Mhm.
You just have the numbers, but how do you break that bigger problem into smaller things, and then how do you see the how can you make decisions?
Mhm.
Like which part is the blocker?
Right.
Like you might have a lot of ad impressions, but if the product is not good enough, you're
Right.
not able to convert trial users to occasional users.
Mhm.
How do you identify all those bottlenecks?
Right.
It's only when you have the problem statement, you find out the different steps involved, and then trying to identify, okay, where am I going wrong in
Right.
this journey? And there is one more example on the economics prize where
Right.
I show how the reinforcement loop helped in compounding the knowledge and helped us in make progress.
Mhm.
Yeah.
Um, all right. Uh,
Yes. Can someone learn systems thinking without an engineering background? Of course.
mhm.
And all the examples that I mentioned was non-engineering related.
Mhm. Mhm.
Uh, if yeah, someone should if someone is interested in, okay, I would recommend people to read about system dynamics
Mhm.
by Professor J Forrester,
Right.
where he tries to talk about problems or different things as stocks and flows.
Mhm.
And then we have the free business simulation library
Mhm.
where you can drag and drop this component and then try to model non-engineering systems.
Right.
um, I would also recommend the study group that I mentioned. It's called Guiding Principles in Modeling and Simulation.
Mhm.
That's available in Wolfram U, free of cost, of course. And that's spread across 10 different days.
Mhm.
And that was very popular and very well received.
Mhm.
And that has like 50 or 60% of the models are non-engineering based.
Exactly.
So I think that is a very good resource for people to check.
And it definitely shows that Modelica is not only focused
Yes,
on engineering.
I would highly recommend,
Mhm.
like, if you have the time, please watch this Guiding Principles for Modeling and Simulation. It's
Mhm.
full of non-engineering examples, and it was a very engaging study group that we did along with our friend Vedat as well.
Right. Uh-huh.
It was fun, and
Mhm.
the thing was, the sessions were planned for 1 hour,
Mhm.
and it went for 1 hour 40 minutes.
Yeah.
So like, and that was every
Uh-huh.
day.
Right.
So that was very engaging, and I would recommend anyone to, like, with a non-engineering background, if they want to see how systems thinking is applied,
Mhm.
I would recommend that study group as well.
Mhm.
And also, you can read my book.
Of course. That's that's also a possibility.
Yes.
All right. I
Okay.
guess we are probably done with
Yes,
the
I think we
questions.
have taken a lot of questions,
Mhm.
and if there are some questions that you still have,
Mhm.
please feel free to reach out to us on LinkedIn.
Mhm.
You can reach out to me on LinkedIn, or you can post your questions in Wolfram community, and we have a lot of experts there to guide you. Um, right.
Mhm.
And this book is available on Amazon if you want to read. I would highly encourage everyone to read. And if you have feedback, please feel free to, please don't shy away. And I'm always open to constructive feedback.
Of course. Of course.
Uh,
Um,
In a single concise sentence for
oh.
Ankit Naik, what is a model? Oh my God.
Good question.
Yeah, what's a model?
Um,
Um,
I guess it's yeah, a representation.
yeah,
Mhm.
a model can be, okay, right. I would say a model is something uh, that mimics. A model is something that, okay, a model cannot be everything, right?
Right. Mhm.
So, model is something that tries to mimic some physical reality
Mhm.
through equations, through empirical data, empirical relations.
Mhm.
It's a representation of the reality
Mhm.
with a lot of stars,
Right.
with a lot of
Mhm.
assumptions, with a lot of boundaries. But it's basically a representation of something that you see in the reality that has a purpose,
Right.
given a lot of simplifications and assumptions.
Right.
Because you cannot have a model of something,
Mhm.
like, all models are wrong, right?
Mhm.
But model has a purpose,
Right.
and for your application, is it able to solve that purpose?
Yeah. And as long as it is useful to you, then
Yeah, as
yeah. Mhm.
yeah.
That's good. Um, says, will all these examples in the book be available for purchases to try it out in System Model Mathematica.
Yeah,
Mhm,
yes.
mhm,
All the examples that I have used in my book are publicly available. Maybe in the second edition, I will uh,
mhm,
link them from individual chapters. But yes, all the examples are actually publicly available that I have shared to my LinkedIn post and things like that. I have not compiled it yet, but I think I will compile it and have it. There were some complication involved with distribution and
mhm,
rights and things like that,
mhm,
because of which I didn't do it.
mhm,
I was a bit like I wanted to be safe,
mhm.
but I can perhaps compile it as a LinkedIn post, linking to different places where I have these models.
Right.
Yep.
So I guess we are good to go.
Yep. Thank you,
Mhm,
everyone.
yeah.
Thank you for all the people who are watching this
Mhm,
episode. I hope we did not waste your time, and
mhm. Right.
we were able to share some of our insights.
Mhm,
Uh, Please feel free to read the book,
mhm.
and we're open for any feedback that you have.
Yeah.
Yep. Thank you.
Yeah. Take care and see you next time.
Yes.
Mhm.